Subprocesses. As discussed, BPMN is a hierarchical modeling language. We briefly discussed task and subprocesses already, but let's discuss the use of subprocesses in more detail. Subprocesses are compound activities, which means they are composed of multiple flow objects. Subprocesses are both an activity and a process in the same time. An unexpanded subprocess looks like a single activity or task in the top-level diagram, but the activity can be opened or expanded. When you open up or expand the subprocess, you will find a detailed process with a start and an end in the child-level diagram. In this subprocess, there can be other collapsed subprocesses, which again can be opened or expanded on the grandchild level of a diagram. This nesting of subprocesses in BPMN is not limited by the specification. In theory, you can add as much layers as you need. My advice is, however, to start with the top-level diagram that only describes the most important process steps. Then, if more information is needed, you can further specify subprocesses. There are different ways to model subprocesses, also depending on the tool you use. Some tools allow you to expand the subprocess on the same canvas, others don't. If you draw a complex subprocess with, for example, multiple lanes or much process steps, it's better to use a hyperlinked canvas or a child-level canvas to model the subprocess. The BPMN 2.0 specification allows you to use both inline expansion and hierarchical expansion with an unlimited number of child-level diagrams. As you can see on this slide, in the first example, the subprocess is first displayed as an opaque rectangle. The flow objects that compose the subprocess are not visible. In the second example, the subprocess is expanded in a child-level diagram, which is also known as hierarchical expansion. From this viewpoint, you are able to see the flow objects that compose the subprocess. In the third example, the subprocess is visualized using inline expansion. As you can see, the shape of the subprocess is enlarged and the flow objects that represent the subprocess are placed inside the shape of the subprocess itself. As discussed, I prefer to use a hyperlinked canvas to display subprocesses, since it's more easy to expand the model over time and you have more space to model complex processes. Subprocess features. There are some things you need to keep in mind about subprocesses. When a sequence flow arrives at a subprocess in the top-level diagram or parent-level diagram, this immediately triggers the start of the subprocess. This means that in the child-level diagram, you cannot use specific triggers since the process is initiated at the top-level diagram. Specific triggers should thus be included in the top-level diagram, not in the child-level diagrams. Subprocesses have the same containment rules as pools. Sequence flows cannot cross subprocesses boundaries, since that would mean that a process flows from one level to another, while a subprocess should have a clear start and end state. Why use subprocesses? Subprocesses are a great feature of BPMN since they enable the hierarchical modeling style of BPMN. When you start with modeling a business process, first create a high-level overview without too much detail. Then, later on, when you advance with describing, analyzing and improving the process, add detail with subprocesses and repeat the describing, analyzing and improvement practice. Following this high-level method, you won't end up with over-detailed models that make understanding and improving the process more difficult. It also helps to focus on what is most important instead of modeling unnecessary details which you don't need at this time. They are also valuable to summarize a process that you don't fully understand yet. On top of that, nesting subprocesses in a diagram helps with clear communication with different stakeholders, since you can switch between multiple viewpoints addressing the concerns of different stakeholders. Expanding the model. Let's apply the knowledge of subprocesses to the existing order process. We already marked the fulfill order activity as a subprocess. We will expand the process hierarchically, which means we will use a hyperlink to go to a blank canvas where we will specify the order fulfillment process. Open a new canvas in Lucidchart or your tool of choice. On this canvas, we will model the following process. Unspecified start event, since the subprocess is immediately triggered at the parent level diagram. Check order, an automated service, followed by a gateway which tests if an order is in stock, yes or no. If an item is in stock, we will pick the stock and ship the order. Those two tasks are manual user tasks. If the order is shipped, the process ends with the fulfilled OK end state, which has the same name as the gateway that tests the outcome of the fulfillment order subprocess in the parent level diagram. If the item is not in stock, we will end the subprocess with the end event out of stock. As discussed in the pools and lanes lecture, pools contain the entire end-to-end process. That means that the pool from the top level diagram is inherited to this level of the diagram. You can draw a pool around this process, but it's not necessary. It's important, however, since the pool is inherited from the top level diagram, that the pool name is the same on all levels of the process. As discussed, lanes can be specified independently in every process level. You are thus able to use lanes in this child level diagram that can be different from the lanes used in the top level diagram. Since this process is pretty straightforward, we won't use lanes in this child level diagram at this moment.